Welcome to class number 29. In this class, we will discuss a concept called VRRP, Virtual Router Redundancy Protocol. In the last class, we discussed about port channel, which is adding physical layer redundancy. So here we are discussing about VRRP, which provides device level redundancy. So the topology for this lab is we have a PC1 and we have a switch and we have two routers. So in normal scenario, you have like maybe 200 devices in this behind this switch. So let's say we have 200 PCs. Okay, and let's say we only have one router R1. So you configure all the PCs with the gateway as 10002. Okay, so this looks good. So whenever these PCs try to reach another networks, they have to send the packets to the R1. So what they do is they create a ARP request who has 10002 and R1 will respond, and they will put that in the destination MAC address to forward any packets to a different network. So the packets will come this way. So if this links goes down, then the gateway will be not reachable. For that you can use the concept of port channel. But what if this R1 device went down? So you will lose the gateway. Okay, so if you would like to have a backup, you can have another router. So here you will give a different IP. But whenever this goes down, the PCs are configured with the gateway as 10002. So they still try to send the package to R1. So but you cannot go and change all the PCs gateway address to the different address. So it's not feasible in real time because the device can go down at any time. So we need to have an automatic failover of the gateway. So we cannot give two IPs as the gateway. So to resolve this, we can use the virtual router redundancy protocol. In VRRP, what we do is we create an additional IP address, but this is not tied to any of the interfaces. Okay, so this will be like a floating. So it can be either here or either here. Okay, in VRRP, we keep the interfaces that where we would like to create a virtual gateway in a one group, VRRP group. So in this example, let's say we put it in the group 1, and then we assign priority for each interface in this group 1. So for this interface, let's say we will give 200, and by default the priority value will be 100. So let's keep it as 100 here. So they talk to each other, and whoever has the highest priority, they will keep this IP address. Okay, and then whenever R1 goes down, when R2 detects that R1 is responding to any of its VRRP messages, it assumes that something wrong with the R1 and it will take over this IP. Okay, so for each virtual IP they will have a virtual MAC. Okay, so normally when the PC1, when you just have a physical interface with this IP, normal IP, when it sends the ARP request, it will reply back with the interface MAC address. So in this case, it will create a virtual MAC address because we don't want to tie this IP to any of the physical interface MAC address. So that's why it will generate a virtual MAC address. So when PC1 will send ARP request for this virtual IP, it will get the virtual MAC. Okay, so whenever PC1 sends the ARP request for 10001, in VRRP only one router will be in the master state. So in this case, if both are up, based on the priority, R1 will be the master. So this is the only one will be responding to the ARP request. Okay, so switch 3 will learns about that MAC address through Ethernet 2 only. Whenever this went down, then R2 will start responding to the ARP request. So R1 will not respond, maybe it went down, right? So only R2 will respond. Okay, so now R2 will respond for the 10001 because it will take over the master role in the VRRP. So now switch learns that MAC address from the Ethernet 3. So now all the traffic will go here. So here on the PCs we put the gateway as virtual IP, which is .1, so that no change needed to be done on any PCs. So when the R1 comes up, then it will go back here because that is a feature called preempt. So what that will do is whoever has the highest priority, once they become available, they will take over the master role. If you don't enable the preempt, R2 will be the master role even though R1 comes back up. Okay, so these are the three concepts you need to remember: VRRP, group ID, priority, and preempt, and virtual IP, virtual MAC. So let's see how we can configure this. So as you can see on the PC, I am giving the gateway IP as 10.0.0.1, which is the virtual IP. So configuration on the R1 is you go to Ethernet to no switch port IP address. So far everything is same here. Then you will mention that VRRP group ID and its priority and what is the virtual IP you want to use. So these settings should be similar on both devices because you are putting those two into the same group and you are assigning the same virtual IP. But for the priority I did not give anything because the default priority is 100. Okay, so here I am giving to a priority 200 because I want R1 to be the master role. So once you configure this, they will exchange messages, VRRP messages, and they form the virtual IP. So let's verify the status. So on R1, show VRRP group 1 interface Ethernet 2. So state is master. Okay, so that means it is having the virtual IPv4 and it will respond to the ARP request. Okay, and you can see preemption is enabled or not. And in any group, if you see who everybody should know who is the master is. So in this case, R1 will know that master in this topology is 10.0.0.2, which is its own IP address. So it is local and priority is 200. Okay, so let's verify the same thing on R2. So state is backup because it has the lower priority and it has the virtual MAC, but it won't respond at this stage because it is in the backup state only. And priority preemption is enabled, and priority, even though we did not configure it, it is the default value. Okay, then R2 knows that whoever is the master router is 10.0.0.2 and master priority is 200, but you don't see local flag here because this device is not the master. Okay, so in VRRP you can have multiple routers, so you can have R3 as well for additional redundancy. Okay, so once VRRP is up, everything should work fine. So let's verify the status. So we have 10.0.0.1 as gateway. So I'm trying to ping 10.0.0.1 from the PC, which is the virtual IP. It is working, and 10.0.0.2 is also working. 10.0.0.3 is also working. So when we ping 10.0.0.2, it's like a normal packet going to this way. 10.0.0.3 this way. Virtual IP is this way. Okay. So let's see the ARP entries. For 10.0.0.2, it will be the interface MAC address of this one, and 10.0.0.3 it will be the interface MAC address of this one. But for 10.0.0.1, if you see, it is a little bit different. It is a virtual MAC address. Okay, let's go and verify it on the switch side to confirm whoever is responding to the 10.0.0.1. So let's examine where you are learning this 5F 10.0.0.2. 5F you are learning from Ethernet 2 from here. So that is good because 10.0.0.2 is here. And let's check for 10.0.0.3 ending with 6.9. 6.9 you are learning from Ethernet 3 from the switch standpoint. That's good because it is here. So now let's verify where switch is learning about the 10.0.0.1. 10.0.0.1 has the MAC address of this 0101. If you go and check 01 and 01, it is learning from Ethernet 2. Means virtual IP also responding from this side. Okay, and 6800 is the PC, so that obviously it is learning from this side. So as you can see, 10.0.0.2 and 10.0.0.1 both are coming from this side. So this way also we can verify that who is owning the virtual MAC address. Okay, so now let's create a fail scenario. So instead of shutting the whole device, what I'm trying to do is I'm just shutting down the Ethernet 2. Okay, so you can completely shut down the router as well. So here I'm just reproducing the VRRP fail on the R1 by shutting down the Ethernet 2 interface. So once we shut it down, let's try to ping 10.0.0.1. So it is working. That means the virtual IP might be moved from here to here. So that's why it is responding, because there is no way this, if R1 is the master and holding the 10.0.0.1, as we shut down the interface, there is no way that it will respond, right? So some other device responding in this case. And 10.0.0.2, as you can see, it's not reachable because we shut down this interface. 10.0.0.3 is reachable. Good. If you do show ARP, now we only have entries for 1 and 3 because 2 is not reachable. And 1, you can see the same VMAC address, and 3, the physical interface address here. So now let's verify that if really R2 is responding for the 10.0.0.1. If you look at the VMAC, now it is learning from the Ethernet 3. So that means R2 is now holding the 10.0.0.1 and responding to the packets. Okay. So let's verify the VRRP status when it is in the shutdown state. So I'm doing the same command, Ethernet 2. If you see, the state is stopped because the interface is in the down state. Okay. So currently there is no master router because it is not any participating in any VRRP messages or anything group, because the interface in the shutdown state. Let's verify it on the R2. R2 state is master. Previously it was backup, now it became master because it has the next lowest priority in this topology. And preemption is enabled and priority is 100. And who is the master router here? 10.0.0.3, so which is local. So now you can see this is the only device currently in the topology, and that's why it has the master router even though priority is 100. Okay. So this way we can use the VRRP to provide gateway redundancy. So PC1 will have the gateway redundancy. So the gateway can be like assigned to the master, and whenever the master fails, the gateway will be moved to the next available backup. So in VRRP, you can group multiple routers to participate, and you can have additional redundancy. So to test the failover scenario and verify the connectivity, build the similar topology, and first verify VRRP is in good state on both R1 and R2. Then from PC1 start a continuous ping with the -t flag, so that the traffic will be continuously going to the gateway virtual IP. And now you try to shut down the R1. So once you shut down the Ethernet 2 on the R1, this should trigger a virtual IP address mover as per the VRRP configuration. Okay, so to R2. So now if you see the ping response, you should see a 1 or 2 ping loss, because while R2 detecting that R1 is down, it will take some time to. So in the transition time, there will be no one responding to this ping request. Okay, but after 1 or 2 ping loss, R2 will take over the virtual IP, and you should see the ping is continuously running again. Okay. So after shutting down the interface, you can verify the status on and R1, R2, just to make sure R2 is the master and responding to the 10.0.0.1. Also, you can verify the MAC address table on the switch 1 to verify where the virtual MAC is switch learning it from. Okay. That's all for today's class. Thank you.